Hey class, here's to the start of semester two. We are beginning with lesson 5.1, talking about how to solve systems of linear equations by graphing. Now, I know that title might seem a little bit intimidating. So before we get too freaked out, let's just start from the very beginning of the first word. So we already talked in our review the other day about what it means to solve something. We reviewed about how solving an equation would give me an x equals answer. And solving has an answer that we call a solution. So the solution is the answer. And it's the answer because when I plug the number back into the original equation, it gets me some kind of true statement. So when substituting into the original problem, we get a true statement. So far in this school year, when I've asked you to solve something, we've only had one variable. We've been in the type of examples where we might have seen x divided by -2 equals 4. Or maybe a little bit more complicated, 3x plus 7 equals 12. Or maybe even a little bit more complicated, we saw variables on both sides. So 2x plus 11 equals 3x minus 4, something like that. And so we saw lots of different types of equations, but in all of our equations, we only had one variable. Now you might be thinking, well, Mrs. Sullivan, what about when we had things like y equals 2x plus 1? And I'm going to ask you, what did I have you do with problems like this? I never ask you to solve them. When we had problems like this, where we had two variables, a y and an x, I may have asked you to graph it, or I may have asked you to do something regarding function notation, but I never asked you to solve. Okay. And the reason is because when I have an equation with two variables in it and I'm asking you to solve, I actually need more than one equation in order to accomplish that. And that is what we call a system. So a system of equations is simply two or more equations in the same problem. Two or more equations. So whenever you think of or hear the word system, you're just thinking, okay, multiple equations. Now, interestingly enough, if I give you an equation that has two variables in it, like let me give you 2x plus y equals 7, and I'm going to talk about asking for a solution. I want you to solve. Then in order for you to do this, because you have an x and a y, you have two variables. When that happens, you need two equations in your system. If you had 5 variables, you would need at least 5 equations. Isn't that interesting? So, to begin with something here and asking you to solve, I would actually need to give you another element. I would need another set of or another equation. So like x minus y equals 3 or something like that. Now, in order to solve a system of equations, another thing we need to do is know how to write our answer. I'm not actually giving you any steps yet in order to find the answer, but our solution always needs to be written as a point. Let's call it a coordinate point. So it needs to be written in the form x comma y with numbers in those spots for x and y. This is how we start to write our solutions. Again, I have an x and y in my original problem, so I need a space for x and y in my answer. But I am picky. Because this is a coordinate point, I require the parentheses on the outside and the comma in the middle. Because in all of these problems that we're going to be doing, our solution is a point. So it needs to be written as a point. So if you want, go around in your notes and just kind of circle the word point to emphasize that. In our problems that we're going to be doing today, it's going to be very clear that I'm looking for an answer that is a point, okay? When we are solving systems of equations, there are going to be three methods that I teach you. We're only going to do one of them today. And so our first method is to solve by graphing. Okay, that's the other part of the title of the section. Solve, so my answer is a point, a system, more than one equation in the same problem, by graphing. So we are going to be graphing. So anytime we're thinking graphing, shoot. Okay, I need to close out the OneNote here. Give me just a second. Close it out. Oh, it's not giving it to me. There we go. Close it out. Oh, it probably was working there. Okay, and reopen it. Okay. When we're graphing, we're going to be going back and using all of our graphing strategies from last semester. So that's why I had us reviewing y equals mx plus b, because in every single problem today, we're going to be graphing. So we have a couple types of problems I want to get us looking at. And so if you don't have your notes going on graph paper, then go ahead and get out a separate sheet of graph paper because they're going to need to go along with it. I'm going to get my graph paper lines here on my screen because everything else for the rest of today is by graphing. So let's talk about this first example. If I give you y equals 5 over 7x plus 4 and y equals negative 1 over 7x minus 2. And if I'm telling you to graph in order to solve, well, what's going to happen here is that I'm looking for the coordinate point that is the solution to both of these lines, meaning if I put them in to the original equation, it works for both of them. So solutions to a system work for both equations. So, okay, what does that really mean when it comes to how to do these problems? Well, let me tell you. If we are going to solve by graphing, this is what you do. Number one, graph both lines on the same coordinate plane. And then the solution is the point where the lines cross. So it's the point of intersection. That's it. That's it. That's all you've got to do. If I'm looking at this system and I'm asking you to solve, the answer is going to be the point. So some x comma y number is where the two lines cross. So we're going to graph using M and B. So my M for the first one is 5/7, and the B is 4. So we're going to go to 4 on the y-axis. 1, 2, 3, 4. And plot a point. And yeah, these might have some crazy slopes. So we're going to go up 5 to the right 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And put a point. And then because we're graphing and we're trying to find exact points where our lines are going to cross, I'm going to go to my forwards point, but also my backwards point where I go down 5 and then backwards 7. And it's really important when we're doing these kinds of problems to make sure to use a ruler. So I'm going to use my best. Oops, see, there we go. Not very good. And then we're going to do the other line. So our other line, again, on the same coordinate plane. So my M is -1/7, and my B is -2. So I'm going to go down 2. And then my slope is -1/7. So I'm going to go down 1, right 7. And so my line can come this way, but clearly when I'm looking at this, my point of intersection is going to be somewhere this direction. So I'm going to go ahead and count the backwards. So up 1, backwards 1, 2, 3, 4, 5, 6, 7, and voila, there's where they cross. So this point here is the solution. And so now we're going to write this as its coordinates. So remember, if I'm going to name this point by its coordinates, I need to name the x first. So on the x-axis, I go back 1, 2, 3, 4, 5, 6, 7. And then the y is down 1. So my answer is -7, -1. This is the point that is a solution for both lines, both equations of this system. Okay, well, let's do another one. But really, it's as simple as that. So we're not going to make this video very long because it's not that hard. Just graphing. Well, it's tricky if graphing isn't easy for you. If graphing is still hard, then this is going to be maybe a little bit more complicated. So I don't mean to minimize the challenge of it. But the concept of it isn't hard. Graph one line, graph the other, give me the point where the lines cross. I feel like I'm about to sneeze. Sorry. Okay. So what we're going to do once we have our original problem is name the M and B. So in the first equation, what's my M? -1. What's my B? 2. So when I graph the B first. So we're going to go to 2 on the y-axis, and I'm going to put a point. And then my slope over here is -1. And remember, you can put that over a +1. Anytime you have a whole number, you can put it over a +1. And then we do our movement. So this is a negative on top. So we're going to go down 1, but then the 1 in the denominator is positive, so we're going to go forwards. Down and forwards, down and forwards, 1 over 1. Same thing, we can go backwards. Up 1, backwards 1. Up 1, backwards 1. We just flip where the negative's at. So I can go ahead and connect my points here. Okay. And then I'm going to do the next one. So my m is 3, and I can make that 3 over 1. My b is the -2. So I'm going to start with the b. And so I'm going to go to -2 on my y-axis and put a point. And then I'm going to count my slope. So my slope is a +3. So I'm going to go up 3 and then to the right 1. Oh, look, there's my point. It's on the other line. Just for the visual, I'm going to go ahead and give myself one more slope of up 3 over 1 and then connect my points. Now, when it comes to actually naming the solution, I don't want you just to come over here and circle this. Yes, that is the solution, but I want you to write it as its coordinates. Again, where on the x, where on the y. So +1 on the x, +1 on the y. That is your answer. But what happens though if I ask you if a specific point is a solution? Okay, so finding the solution is one thing. We graph and name the point of intersection. But what if I say is the point 5, 1 a solution to the system? Where my equations are x plus y equals 6 and 2x minus y equals 9. If I'm asking you, is a point a solution to the system? I do not want you to graph these 2 points. Okay, that is where most people make a mistake. They'll say, oh, okay, well, let's just graph these and see if they cross at 5, 1. But if I'm checking to see if a point is a solution, just like we talked about yesterday, all we have to do is take the x and plug it in for the x. Take the y number and plug it in for the y and see, do I get a true statement? So in this type of problem, you have to remember that the first number is the x, the second number is the y. So we need to do our substitution. So 5 is going to go in for the x. My equation says plus, and then the 1 is going to go in for the y. And I'm asking, does that equal 6? So is 5 plus 1 6? Well, yes, because when I simplify the left-hand side, I get 6 equals 6. So this is a true statement. But remember, it can't just be true for one, it has to be true for the other one. So we check the point in both equations. And I'm going to write substitution. That's what we're actually doing. So now we're going to take this 5 and we're going to plug it in for this x. I'm going to take the 1 and plug it in for that y. So I'm saying is 2 times 5 minus my y of 1, is that equal to 9? Well, 2 times 5 is 10. Minus 1 is 9. So 9 equals 9. So true. So when it's true for both equations, then it's true for the whole system. So is this a solution? Yes, it is, because we checked the point in both equations. Okay, and just so you can see, because I want you to visually see what's going on. Anytime we want a visual, remember we can go to Desmos, okay? We've done a little bit of work on Desmos together. So if you're wondering, I got this as a true statement, but I just want to double check. Open up your computer and type in the original equation. X plus y equals 6. And then our other equation was 2x minus y equals 9. And then we were checking the point 5, comma 1. So do they cross at 5, 1? Yes, they sure do. All right, that is it for us for today. That is the whole video. So just as a quick, again, little wrap up, we're talking about systems, and systems are simply more than one equation. Our solution is a point written as x comma y. And if I'm asking you to find the solution by graphing, you graph both lines and tell me the point where they cross. If I'm asking you to check to see if a point is a solution, you plug in the x number for the x and the y number for the y and see if it gives me a true statement. If it doesn't work for either one of these equations, if one of these is false, then it's false for the whole thing and the answer is no. All right. You guys have a great rest of your day, and I will see you in class later.